Good morning. Today you are going to see about the concept of microprocessor, that is 8086 microprocessor. So generally this microprocessor and microcontroller subjects involves two major categories. One is your 8086 microprocessor, another one is your 8051 microcontrollers. This microprocessor is an electronic component that is used to perform a specific work. It contains various elements like transistor, resistor, diodes. These all elements will be combined together to perform a particular task, that is a processor. So generally you might aware of the processes in system. So that processor will process these major blocks. First one is your input device. The processor will receive some signals from input device that can be displayed with the help of some output device. For example, if a system is considered, the keyboard will be of input device, the monitor will be of output device, the memory unit will be of RAM. So next one is your RAM and ROM. Next is your major processor. So the CPU is the processor device. Once the input will be given means that input will be reached the processor, that processor will controls everything and that can be displayed with the help of monitor. So next one is your evolution of microprocessor. The microprocessor it is started initially at 4004 processor, named as 400 processor, and till date it is developed to many number of versions. So initially it is introduced in 1971 and later till 2020 they have developed a new version of processors. So Itanium, some various advanced processors are there. So as I said earlier, this particular subject will holds the two major blocks. One is your microprocessor, another one is your microcontroller. The microcontroller will have a specific application in embedded system. So majorly many applications will be used the microcontroller ICs. So a major drawback is the cost of the system of in a microprocessor is increased when compared to microcontroller, and this microprocessor, it cannot be used in compact systems, and this the memory and input output has to be connected externally, and in order to connect these devices externally means the circuit and the device setup will be of large size. So these drawbacks will be overcome with the help of microcontrollers. So first you are going to see about 8086 microprocessor. These are the features. So major features include, it is a 16-bit processor. It has a 16-bit data bus. It has a 20-bit address bus. And the memory capacity is 1 MB memory. So these 4 points will be of key features of 8086. Other than is individual specific IC requirements and IC present package availability, these registers will be available in ICs 8086 IC. But the major application is 16-bit processor, 16-bit data bus, 20-bit address bus, and 1 MB of memory. So this is the internal architecture, that is a block diagram. Like a block diagram, this architecture diagram will show the major blocks in 8086. So the two and foremost blocks in the 8086 architecture is execution unit and a bus interface unit. So these major blocks will hold some sub blocks. So first one is here, the bus interface unit will hold the memory interfacing unit, segment registers, instruction pointers, instruction queue. These are the small blocks which comes under the bus interface unit. Bus interface unit, the name itself indicates interfacing with outside world. So the data can be obtained with the help of some outside communication devices that can be transferred with the help of address bus and data bus to the execution unit. The execution unit will perform the operations of particular data to be accepted, and that can be stored in a particular registers and it can be further communicated with the other displaying devices. In next, we are going to see about the individual blocks which is depicted in this architectural diagram. So first one is your two major blocks. One is your bus interface unit. Next one is your execution unit. So bus interface unit is, it fetches the instruction or it reads from the memory and it can be used to store the data to the memory. So execution unit is, it receives the program from the bus interfacing unit and execute these instructions in order to store the results in particular registers. We are having 4 types of registers. So that is in general purpose registers, we are having 4 types of registers. A register, sorry, AX register. Next one is your BX register. Next one is your CX register. And last one is a DX register. So first, as I said earlier, the general purpose register will hold 4 types of register. AX, it is also called as accumulator register. BX, it is also called as base register. CX, it is also called as count register. DX is also called as data registers. Each and every type of registers will hold the different applications. For example, this accumulator register will be used in IO operations and string manipulations. But these base registers will be used to point the addressing modes, or it is used as a data pointer. Next one is your count register. This count register is used as a counter in string manipulation and shift and rotate instructions. The data registers will be used as a, in order to identify the port number in IO operations, this particular data registers will be used. Next one is your segment register. The segment registers will hold the memory of 64 KB. Each segment register is a 16-bit registers which are capable of holding the memory of 64 KB. The code segment register, so it has a 4 segment registers: code segment, stack segment, data segment, and extra segment. The code segment registers can be automatically updated by using a fair jump and fair call and fair return instructions. Similarly, the stack segment can be directly changed with the help of pop instruction. So pop instruction is the stack pointer position can be incremented by 2 locations. And DS register, that is a data segment register, that can be directly changed by using pop and LDS instructions. In extra segment registers, these can be directly changed by using pop and LES instruction. LES in the sense load extra segment, LDS in the sense load data segment. Next one is your pointer register. Pointer register is there will be 2 pointer registers. One is our stack pointer, another one is your base pointer. The stack pointer and base pointer will be of 16-bit registers. The stack pointer is used to point the current location of the stack. That is, the instructions will be stored in a queue. That current location can be used to point with the help of stack pointer. The base pointer will be used during the addressing modes. So the registers will be used especially in based and based index addressing modes. Next one is your index register. There will be of 2 index registers: source index, destination index. So source index registers is a 16-bit register. It is used for indexing, based indexing, and register indirect addressing. So mainly it is used in string manipulation instructions. That is a key point here. Next one is a destination index. The destination index is a 16-bit registers. It is mainly used for index, based index, and register indirect addressing mode. This can be mainly used in string manipulation instructions. Next one is your instruction pointer. So instruction pointer is a 16-bit register. The operation is same as that of counter. So it is automatically updated to next location once the program start to execute it. So it doesn't have the access to the instruction pointer, but it can be executed during the program and the instruction pointer will be modified and stored or restored from the current position of the stack. The flag register is used to indicate the status of the current status of the stack once the instruction is executed. The flag register is a 16-bit register. It contains 9 1-bit flags, 6 status flags or conditional flags, and 3 control flags. These are the flags, various flags. Overflow flag. This overflow flag will be used to indicate if a too large positive number result are generated or negative number is generated. So this position, this status can be indicated with the help of OF flag. Next one, sign flag. The sign flag, if the result is set or reset, what type of result is obtained, that can be indicated with the help of this flag register. The explanation will be depicted with the help of this diagram. OF, DF, OF in the sense overflow flag, direction flag, interrupt flag, timer flag, sign flag, zero flag, auxiliary flag, parity flag, carry flags, etc. So instruction queue. The instruction queue holds the concept of FIFO, first in, first out. So the stack will be of different locations. Once the instruction will be loaded first, that can be fetched as first. That is the concept of FIFO. So why this instruction queue is used means in order to speed up the program execution. So by avoiding the overlapping of instruction during fetching and execution process. Next, ALU. ALU is an arithmetic and logical unit. It is a 16-bit register. It can add, subtract, increment, decrement, and do various logical operations such as AND, OR, and XOR operations. Control unit. The major control signals behind this entire operation is read, write, memory, or input, output. If you need to read a data to a particular location means these control signals will be given to the processor. So once the processor identifies that read signal will be given means the final result will be read into a particular location or read from the locations. So next, various instruction sets. These instruction sets are used to understand the concept of like a syntax. So it is used to indicate the how these instructions will be used in further programs. So various types of instruction sets are there. So data moving instruction, arithmetic instruction, logical instruction, string manipulation instruction, control transfer instruction, input output instructions, and other instructions. Addressing modes. So various types of addressing modes. So in upcoming topics, you are going to discuss about this instruction set in a detailed manner, and addressing modes you are going to see with each an example under each category elaborately. So next one is your interrupts. So various types of interrupts are available to generate interrupts. Interrupt is nothing but an external disturbance in order to do a service for the particular processor. So first one is your maskable or non-maskable interrupt. Next one is your software interrupts. So hardware interrupts. In the hardware kit, there will be a key named as INT. If that particular key is pressed means this interrupt will occur. In software interrupts, you are going to use the program line int. So if you type the int in the program means mnemonics means it will accept that processor will accept that int as given as software interrupt. That's all. These are all about architecture of 8086. This is an important topic that you have to consider as an first and foremost priority.